Hey guys, Miss S here. We're going to cover graph and compare integers, numbers, and their opposites and absolute value. So let's get started. We're going to look at graphing and comparing integers. We did this a little bit last week, and we're going to continue on and take a look at what this looks like. So more specific than the rational numbers are integers. And integers are whole numbers and their negatives. When comparing integers, you will use the math verb such as less than, greater than, approximately equal to, or equal to. So to graph an integer on a number line, place a dot above the number you want to represent. So some of those verbs that this was just talking about, when you're comparing, we use symbols. So we use the greater than symbol. Gotta get my pen out here. Got our greater than symbol. We've got our less than symbol. Approximately equal to. So would look something like this, or equal to. Now we're not going to worry about this approximately. The main ones we're going to look at right now are greater than, less than, and equal. So when we're graphing, let's take a quick look. We are going to look at the solution. We're going to look at example 4. So here it says compare the numbers 2 and a -5. So a number line has been drawn out here. And on that number line, we have 0 in the middle. We go up 1, 2, 3, 4, 5, 6, positive. And then it goes down the same on the negative. -1, -2, -3, -4, -5, -6. So the first thing we're going to do is plot the numbers. Here they plotted 2, and over here, -5. Now that we've got both of those on that number line, we can compare the integers by noting, let me get my thing here. Ugh. Well, that's just not cooperating with me. Okay, we can compare integers by noting which is greatest and which is the least. The greatest number is the number that's farthest to the right. So when I'm talking about moving farthest to the right, it's going to be on this side. And the least is the farthest to the left. So the least would be all the way on that side. So the farther you are to the left, you're looking at the least. The farther you are to the right, you're looking at the greatest. So in the diagram above, we can see that 2 is farther to the right on the number line than -5. So we can say that 2 is greater than a -5. We use the symbol greater than to mean greater than. So it's just an arrow. We're going to have the fat end pointing towards the greater or the bigger number. So it'd be written like this, a negative or a 2 greater than symbol, -5. So let's look at numbers and their opposites. Every number has an opposite, which represents the same distance from 0, but in the other direction. So let's take a look here. We've got 0. Now I've got a number that's not quite 5, and there's an opposite on the other side, not quite -5. So a special situation arises when adding a number to its opposite. You're going to get the sum of 0. This is summarized in the following property. Now we were talking about the additive inverse property the other day. That's one of the properties of real numbers. So what this means is for any real number, if you make a the number, a plus a, the opposite, negative a, equals 0. So if I take a, I add it to its opposite, negative a, I will get 0. So that brings us to our absolute value. So absolute value, we looked at a little bit at this in some of our problems already when we're ordering numbers, represents the distance from 0 when graphed on a number line. For example, the number 7 is 7 units away from 0. The number -7 is also 7 units away from 0. The absolute value of a number is the distance it is from 0. So the absolute value of 7 and the absolute value of -7 is 7. So when we write the absolute value of a -7, it looks like this. You're going to have 2 bars that go up and down, and you're going to put that -7 right in the middle of it. We read the expression, the absolute value of x, like this. We would say the absolute value of x. So treat absolute value expressions like they are parentheses. So if you were working with PEMDAS, you would treat them like they were parentheses. If there is an operation inside the absolute value symbols, evaluate that operation first. The absolute value of a number or expression is always positive or 0. So you're never going to have a negative number when you're dealing with absolute value. It cannot be negative. So with absolute value, we are only interested in how far a number is from 0, not the direction. So let's try a couple of examples here. We have got 5, let's start out with A, 5 plus 4. So I'm going to scroll up here. So we have the absolute value, I'm going to write it right here, 5 plus 4. If we look here, it's written the absolute value of 5 plus 4. We'd add 5 and 4 inside, like if we're adding inside parentheses, and we get the absolute value of 9. All you do is you're going to drop the bars, and your answer is 9. It's 9 spaces from 0, 9 steps from 0. So let's look at our next one, our next problem. We have 3 minus the absolute value of 4 minus 9. So when we look at, we're going to do the absolute value first because it's like doing parentheses. 4 minus 9. So what is 4 minus 9? 4 minus 9 is a -5. We're just going to carry our 3 over and our minus sign over. Now, notice we still got our absolute value bars up. What we do from here is we bring down our 3 and our minus sign. Now we figure out what is the absolute value of a -5. It's just 5. Remember, absolute value is always going to be a positive number. So now we're ready to finish solving this. If I have 3 and I subtract 5, I get a -2 as my answer. Let's look at C. C is the absolute value of a -5 minus 11. In this case, we have a negative number and we're subtracting a number or another negative number. We're going to add, we have 2 negatives. So 5 plus 11 is 16 and it's negative. So -16. Now we're going to find the absolute value so we can get rid of our bars. The absolute value of 16 is 16. And for D we have the absolute value. Oh, we have a negative. Now this is the catch. The negative is on the outside. It's not part of the absolute value. Only the things in the brackets are part of the absolute value. So inside the brackets, I have 7 minus 22. 7 is a positive. So when I have a positive, I have a negative, I have a tug of war going on. The 22 is negative, the 7 is positive. So I know I'm going to have to subtract, but I know negative is going to win because that one is bigger. So if I take positive 7, subtract 22, I get negative 15. And we went ahead and wrote negative 15 on the outside here. Notice this negative sign has carried over. They wrote it on the outside. They carried it down here. They moved it. The negative number is still on the outside. But now we need to evaluate what is inside those absolute value bars. And inside the absolute value of a negative 15 is positive 15. So we have, let me erase my writing so we can take a better look at this. If we look, we put parentheses up because I want that negative sign that was outside to stay separate from my absolute value. When I combine them together, 15 was my answer. I'm going to keep that negative sign there. So the answer to this one remained was negative 15 because that negative sign was on the outside of the absolute value. All right, so let's just take a quick moment and we are going to go ahead and watch this video on integers and rational numbers from Khan Academy.
And rational numbers. So this first one here, the tick marks on the number line represent evenly spaced integers. And just in case you forgot what integers mean, that essentially is the counting numbers, including 0, and the negative counting numbers. So 1, 2, 3, 4, those are all integers. 0 is an integer. -1, -2, -3, and so on and so forth. There's all integers. You might imagine the whole numbers. Those are also another way of saying the integers. So they say find the values of A, B, C, D, and E. So these are evenly spaced. And this is 0 right here. And this is 21. Let's see how many tick marks it takes us to go from 0 to 21. We have 1 tick mark, 1, 2, 3, 4, 5, 6, 7 tick marks. So 7 tick marks take us to 21. And they're evenly spaced. They tell us that. Evenly spaced tick marks. So if 7 of these take us to 21, there must be 3. Each must be a jump of 3. This must be 3, 6, 9, 12, 15, 18, and then bam, 21. And the way I figured that out, I said 7 tick marks gets us to 21. 21 divided by 7 tick marks is 3. So each of those increment by 3. So this goes to 0. And then this must be 3 to the left of that. So it's negative 3 right there. So what are A, B, C, and D? A is -3. A is equal to -3 right there. That's a 3. B is equal to 3 right there. C is equal to 9 right there. D is equal to 12. And E is equal to 15. Not too bad. All right. Determine what fraction of the whole each shaded region represents. All right. Let's see. Here we have 3, I guess you could say 3 sections of this pie. So in our denominator, which is the bottom of our fraction, we'll write there's 3 possible pieces, and only one of the possible 3 sections is shaded. So 1/3 is shaded. So this first one is 1/3. The second one is how many sections do we have? And all the sections are equal sized. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sections. 12 sections. How many are shaded? 1, 2, 3, 4, 5, 6, 7. So it is 7/12. That's what this shaded region represents. And then here, what do we, let's see, how many squares do we have? We have 1, 2, 3, 4, 5, 6, 7 along this side. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 along that side. So we have a total of 70 squares, 7 times 10. We have 70 squares. And let's count how many are shaded in. Well, this is going to be 7 right there. This is 7 right there. That is 7 right there. That is 7 right there. So let me add this up. So far I have 28. That's 7 times 4. 28 plus, let's see, I have 2. This is 2, 2, 2, 2, 2, 2, 2, and 2. So how many 2's are there? That's 1, 2, 3, 4, 5, 6, 7, 8 2's. So that's 8 times 2. That's 16. So 28 plus 16, 28 plus 10 is 38, plus another 6 is 44. So we have 44 of the 70 squares filled in. And we can write this rational number in simpler form. We can simplify it. Let's see, the numerator and the denominator both are divisible by 2. So this is equal to 22 over 35. And that's about as simple as we can get. This is divisible by 2 and 11. This is not divisible by either 2 or 11. So there you go. That's the fraction in simplest form. Problem 3. Place the following sets of rational numbers in order from least to greatest. So let's do part A. I might not do all of these for the sake of time. 1/2, 1/3, and 1/4. So if you think about a pie going on, if you take a pie and divide it into just 2 pieces, 1/2 is half of that whole pie. That right there is 1/2. This right here, 1/4. 1/4 is, you take the same pie. You take the same pie. 1/4 is just that. So clearly 1/2 is greater than 1/4, or 1/4 is less than 1/2. Is less than 1/2. I'll write it like that. And 1/3 is right in between. If you did 1/3, it's maybe harder to visualize here, but if this was 1/2, if we divided this into thirds, 1/3 is less than this. So if we divided this into thirds, 3 equal sections, 1/3 would be just like that right here. And 1/3 is more than that. Okay, there's multiple ways we could visualize this. So 1/4 is less than 1/3, which is less than 1/2. In general, the larger your denominator, the smaller the fraction. I have only 1 out of 4. That's less than 1 out of 3. And that's even less than 1 out of 2, which would be even less than 1 out of 1. So that's our first one. We put that in order: 1/4, 1/3, 1/2. Let me just do part C, just for the sake of time. So we have 39 over 60. We have 49 over 80. And we have 59 over 100. So the easiest way to do this, if you had a calculator, you would actually just divide each of these numbers out, and you would get a decimal. And it's very easy to compare decimal numbers. But let's see if we can do this a little bit more artfully. So we can approximate it. And then we could say that this is a little bit less. So 39 over 60, it's almost, I'll make those squiggly equal signs for almost. It's approximately 40 over 60, which is equal to 2/3. So this is almost 2/3, a little bit less than 2/3. This right here, 49 over 80. 49 over 80. It's almost 50 over 80. So it's almost 5/8. And then this right here, 59 over 80. 59 over 100, sorry. It's almost equal to 60 over 100, which is equal to 3/5. And just to get a sense of, at least now we might be able to do it in our head, 2/3, that's approximately equal to 0.66 repeating. You say 667, roughly equal to that. That's the 2/3 right there. Let me do it in that color so you know what I'm talking about. So this is approximately 0.667. Not exactly, we're estimating. This right here, 5/8. So the way I always think of eighths is 1/8 is 0.125. So 5/8, like, let me just divide it right here. Let me just do the work. So if we take 8 goes into 5, put some decimals right here. 8 goes into 5 0 times. 0 times 8 is 0. 5 minus 0 is 5. Bring down, this is 0. 8 goes into 50 6 times. 6 times 8 is 48. 50 minus 48 is 2. Bring down a 0. 8 goes into 20 2 times. 2 times 8 is 16. Subtract, we get a 4. Bring down this 0. 40. 8 goes into 40 5 times. So this right here is 0.625. Not exactly. It's a little bit less than this. This is a little bit less than that. And 3/5 is pretty straightforward. 3/5 is the same thing as 6/10, which is approximately equal to 0.6. So this is a little bit less than 0.6. This is a little bit less than 0.625. This is a little bit less than 0.667. So if you put them in order, this is the smallest, then this one, then that one. So let me write it down. So the smallest is 59 over 100, followed by 49 over 80, followed by the largest, which is 39 over 60, which might be a little unintuitive because this actually has the smallest number in the numerator, but it also has the smallest number in the denominator. So you actually have to work it out. See, they're actually reasonably close to each other. Let's do problem number 5. Find the opposite of each of the following. And when they say opposite, I think they mean find the negative or find the reflection on the number line. So we essentially just have to multiply all of these numbers by -1. So for part A, the opposite of 1.001 would be -1.001. For part B, the negative of 5 minus 11, well, we could write it, it's going to be -1 times, well, what's 5 minus 11? 5 minus 11 is -6. -6. This number right here is -6. So the opposite of -6, -1 times -6, is going to be equal to 6. Part C, x plus y. The opposite is going to be -1 times x plus y. Or we could have just written negative times x plus y. You distribute the -1. This is equal to -x. And then -1 times plus y minus y. Finally, part D, -1 times x minus y. Right? I'm just taking the negative of everything. So I'm taking the negative of this. And so this is going to be equal to -1 times x, negative x, then -1 times minus y, or negative y, that's plus y. Or we could write this as y minus x. And that's actually a neat thing to remember later on when you're manipulating things algebraically. The negative of x minus y is y minus x. We just did that right there. The negative of a minus b is b minus a. You just swap the two when you take the negative. And we just proved it for you right there. All right, let's do a couple of these. Simplify the following absolute value expression. Absolute value is essentially telling you the distance from 0. So for example, if that's 0, if I have the number 4, how far is 4 from 0? The absolute value of 4, well, it's 4 from 0. So you just say it's 4. So the absolute value of positive numbers is just the number. And then let's say I had -3. How far is -3 from 0? Well, I don't care whether it's to the left or the right of 0. It's just 3 away from 0. It's 3 to the left, so this is going to be 3. So one way to think about absolute value is whether it's positive or negative, it becomes positive. It's that far from 0. So let's do these. So 11 minus the absolute value of negative 4, this is equal to 11 minus the absolute value of negative 4 is just 4, which is equal to 7. I'll do every other one of these problems. The absolute value of negative 5 minus 11. So that'll be equal to the absolute value of negative 5 minus 11 is negative 16. It's the absolute value of negative 16. The absolute value of negative 16 is just 16. It's 16 to the left of 0. You could view it that way. You can just get rid of its sign. And then finally here, let's do part E. The negative of the absolute value of negative 7 is equal to the negative of, what's the absolute value of negative 7? It's just 7. So it's equal to negative 7. This right here is 7. Anyway, hopefully you found that useful.
All right. So there's just kind of a little information, went over some of the problems from yesterday that we worked on and some of those that we skipped. So today's assignment, we're going to continue working on our problems, but we're going to start at question number 19. So you're going to scroll down. You're going to do problems 19, 21, 23, 25, 27, 29, 31, 35, 37, and number 43 for your assignment. So if you have any questions, let me know. Otherwise, go ahead and get started and get your assignment turned in.